Hello everyone. In this video I'm going to go over the source code that I used to start my 2D platformer with Pygame project. A lot of people have been asking me to post the code that I used in my videos so that they can also do this project. So I decided to make a new series of videos where I walk through the code and show you exactly how I built my game. That way other people can use what I've learned in their own projects. So here I have the source code that I started out with, and I'm going to run this example real quick so you can see what this script does. What we have is a little blue block that I can move around with the arrow keys. If I press the up key, the block will appear to be jumping in the air, and if I jump towards one of the platforms, I can land on the platform and move around the map. You'll notice that as I move around the map, there's a camera that follows the block around. Now that we know what this script does, we can go over the code to see how it does this. So we'll just start at the top here with these first two lines. Import Pygame from Pygame import all. This is going to tell the Python interpreter that I have Pygame installed in my Python directory, and I'm going to be referencing that library in this code. That way when I start using Pygame code, the interpreter will know what I'm talking about. Next we have win width equals 800 and win height equals 640. These variables are going to be used to define the size of the window. These halved values of the window size are going to be used later by the camera. Next is this display variable, which is going to take the window width and height we just defined and put them together into one variable. So the display variable will be a pair of values. After that is depth equals 32, flags equals 0, and camera slack equals 30. Depth and flags are going to be used to initialize the display window, and camera slack is a variable that is never used in this script, so we don't need to worry about that line. It was probably just an idea that was never actually implemented. Next we have our main function. This is the first function that will run when we start the script. First up in our main function is this global statement, global camera X and camera Y. These variables don't exist, so there's no reason to worry about those. Next is pygame.init, and this function will initialize all the Pygame modules so that you can use all the different functions available in Pygame. Before you can use any of the functions in Pygame, they need to be initialized. You can initialize them individually, but the easiest thing to do is just initialize them all at once, which is what this pygame.init function does. So now that Pygame is initialized, we can use this pygame.display.setMode function to create a window. If you look at this first argument, we're passing in the display variable, which is a pair of values that represent the window's width and height. Then we're passing in flags and depth that we defined up here. And I'm going to admit that I don't know what these arguments do. I know that they are optional. I think that these values defined here are the default values that the display function will use if you don't pass in the arguments anyway. So I think whoever wrote this script just put them in there in case they wanted to change them later. I've never needed to change them, so I don't know what they do, but if you want to know, you can look them up in the Pygame documentation. In this script, the display.setMode function is set to a variable called screen. This is so we can make changes to the display by using this screen variable. If you don't set the display function to a variable, it will still create a window, but you'll need to create a new display every time you want to draw to the screen. Since we're going to be drawing to the screen quite often, we definitely want to use the screen variable. Next is pygame.display.setCaption, use arrow keys to move. If I run the script real quick, you can see that this function sets the caption that is displayed at the top of the window. So if I wanted the top of the window to say something else, I could just change the string. Then we have timer equals pygame.time.clock. This is going to create an instance of Pygame's clock function, and we'll be using it later in the script to limit the game's frame rate. After that is up, down, left, right, and running equals false. These variables are going to be used to move the player around, and we'll see how that works later in the script when these variables are actually used. Then there's bg equals surface 3232. In Pygame, a surface is an object that represents an image, so surface 3232 would be an image that's 32 pixels wide and 32 pixels tall, and we will be able to draw in this image and later draw it to the screen. Then bg.convert, so we're going to take the surface we just created and convert it so that it has the same pixel format as the display. Surfaces in Pygame can have different pixel formats depending on whether they're transparent or non-transparent. If a surface has a different pixel format than the display, it might take a little longer for Pygame to draw it, so this isn't really a necessary step, but it might increase performance in certain cases. Next is bg.fill color $0000000. So in this line we are drawing to the surface we created by filling it with solid color. In this case the color is $0000000, which is the hex code for the color black. Pygame has some built-in colors, so in these quotes you could just type black and still get the color black. Also, I believe that when a surface is created in Pygame, its default color is black, so you could just not fill this at all and it would still be black. So there are a few ways to get this particular color, but if you wanted a different color, you could use a built-in color by typing in the name, or you can look up a hex color chart online and find the hex code for the color you want. I think you can also use an RGB format to define a color, so there are a lot of ways to define colors in Pygame, and it's pretty much up to you what format you want to use. Next is entities equals pygame.sprite.group. A sprite group is a container that holds sprite objects, and in Pygame a sprite is a base class for visible game objects. So most, if not all, of our game objects are going to be sprites. Every sprite is going to have some base properties that all sprites will have, but they can also have their own unique properties, which we will see in just a minute when we look at this next line. Player equals player 3232. In this line we are creating an instance of the player class, so if I scroll down a little bit we can see what this class is. So player is of type entity, and if we look up here we can see that entity is of type pygame.sprite.sprite, so the player class is a sprite. As I mentioned, since the player class is a sprite, it has some base properties that all sprites have. Those base properties are this self.image property, which is the visible part of the sprite, and the other property that all sprites have is the self.rect property, which is a property that defines the size and position of a rectangle. Also, like I mentioned, sprites can have their own unique properties, which for this object are its self.xval property and self.yval property. So let's go over these properties real quick to make sure we know what they are. This self.xval and self.yval are the object's x velocity and y velocity variables. Later they are going to be used to move the player around. Then there's a self.onGround property. This is going to be used later to determine if the player is in the air. Then we have the self.image property, which is the visible part of the sprite. It's going to be a surface that's 32 pixels wide and 32 pixels tall. Then we are going to fill it with a color. In this case, it's the hex code for the color blue. We'll convert it, and then we have the self.rect property. Now up here it says init self x, y, so x and y are defined when the object is created. So when we created the object it was player 3232. So x equals 32 and y equals 32, so our rect property is a rectangle that's at position 32, 32, and it's 32 pixels wide and 32 pixels tall. Now you might think, why do we need to say that the player rectangle is 32 pixels wide and 32 pixels tall if we already said that the image is a 32 by 32 pixel surface? This is because the image property is only used for what is drawn on the object. If you were to change the image size to 64, for example, the image drawn on the object would be larger, but the object itself is still 32 by 32 pixels. If I run the example this way, you can see that the image on the player block is larger, but only the 32 by 32 pixel area collides with the platforms because its rectangle is defined as a 32 by 32 pixel object. So the important thing to know about this self.rect property is that it's used to define the object's x and y position on the map and its size when it collides with other objects. The player object also has a few functions built into it, but those won't be called until later in the script, so I'll go over those when we get to them. Right now we'll go back to where we were in the main function when we created the player object. So we created the player object, now we're going to build the level for the player to move around on. We have an empty array called platforms, which is going to hold the platform sprites. Then x and y equals 0, level equals this large array with some strings in it, then there's a for loop. I'm not going to go through this for loop line by line, I'm just going to explain what it does. It's going to start at position 0, 0 on the map, then it will read the first character in the array. If it's a P, it's going to add a platform to the platform array and to the entity sprite group. Since it's being added to a sprite group, that's a pretty good indication that this platform class is going to be a sprite object. We can scroll down and platform is of type entity, which is of the type pygame.sprite.sprite. So it is a sprite. Its image is a 32 by 32 pixel surface that's filled with the color gray, and it has a rect of XY 32 32. So it's a 32 by 32 pixel object, and its X and Y position are determined when it's initialized. So back in our for loop, the first platform would have an X and Y value of 0, 0. Then when the loop reads the next character in the string, it will advance X by 32. So the next platform will have an X value of 32 and a Y value of 0. And the next X value will be 64, and so on. When the loop completes the first line, it will advance Y by 32, so moving down 32 pixels. It will reset X to 0, so the first platform has an X value of 0 and a Y value of 32, and the loop will continue through all the characters in the array until it has created all the platforms at the X and Y coordinates shown in this sort of drawing of the level. So now that the level has been created, we have total level width equals len level 0 times 32. This total level width is going to be used by the camera. This len function returns the length of the first index of the level array, which would be the length of this first string in the array. And it multiplies it by 32 because each character in this array represents a 32 by 32 pixel block. So this length function times 32 gives us the width in pixels of the level. And this total level height gives us the height of the level. The number of lines in the array times 32 is the height in pixels. Next we'll create an instance of the camera class and pass the level width and height to it. And we're using the complex camera function, which I'll go over a little later in script. Then we're going to add player to the entities sprite group. So entities is now a sprite group that contains all the platform sprites and the player sprite. That will bring us to while 1, which is going to be our game loop. While 1 is always true, so all this code inside this loop will run repeatedly until we close the program. First in the loop is timer.tick60. This is our instance of the clock function, and we're setting the tick to 60, meaning that the script won't run any faster than 60 frames per second. Anytime you make a game, you want to set a maximum frame rate so that the game will run at a constant speed. Without limiting the frame rate, the game's speed will be dependent on the speed of your processor. The game will run faster on a faster computer, and the speed will change depending on how much processing power your computer has available. So this is definitely a necessary step, not just for Pygame, but for any game you'll always need a constant game speed. This next block is the game's input handler. We have for e in pygame.event.get. Whenever a key is pressed or the mouse is moved, it goes to the Pygame event handler, and we're using the get function to get the event from the handler. So after we get the event, we test to see what the event is. If e.type is equal to quit, raise system exit, quit. So if the event.type is quit, meaning someone clicked the X button on the window, then it will raise system exit, which will end the program. Then if.type is equal to key down and e.key is equal to k underscore escape. If the event type is key down, meaning a key was pressed down, and e.key is equal to k underscore escape, then the key pressed was the escape key. Then we'll also raise system exit to stop the program. Then we have key down events for up, down, left, right, and space. If these keys are pressed, then up will equal true if the key pressed was up, down will equal true if the key pressed was down, and so on. Then below that are some key up events. This event happens when a particular key is released, in which case up, down, left, or right will equal false. So with this setup, when one of the arrow keys is pressed, one of the variables will equal true until the key is released, and then it will be false again. We'll see how this is used to move the player in just a minute. Next is for y in range 32, for x in range 32, screen.blit bg x times 32, y times 32. So now we're going to use our screen variable to change the display, and we're going to be blitting our bg object, which was the black square that was created earlier in the script, so it appears on the screen. In Pygame, the function for copying one surface onto another surface is called blit. I'm not really sure why it's called blit, but I guess they had to call it something other than draw, since Pygame already has a draw function, and it's just used to draw geometric shapes to a surface. So since we're using blit, it means we're copying one surface onto another surface. In this case, we're copying the black square surface we created earlier onto the display, which itself is a large surface. So let's take a look at this line here, screen.blit bg x times 32, y times 32. First we have our surface we are copying to, which is the display, so screen. We're calling the blit function on this surface, and our first argument is bg, which is a 32 by 32 pixel black square. So the first argument in blit is the surface that will be copied to screen. Then the next argument is a pair of values that tell the blit function where on the screen surface we are going to put the bg surface. Since this is a for loop, first x will equal 0 and y will equal 0. So the first 32 by 32 pixel black square will be copied to the screen at position 0, 0. Then at 1 times 32, 0. Then 2 times 32, 0. Then once it reaches x equals 32 times 32, y will equal 1, x will be 0, and it will continue on like that until y equals 32. And by then the entire screen will be covered by 32 by 32 pixel black squares. Now the reason we have this loop is to fill the screen with black squares on every update before we draw anything. If you try to just draw everything else over what was already there, then everything drawn to the screen will just stay there, and the screen will be cluttered with all the previous drawings. It'll be a huge mess, and you won't be able to see what's going on. So you definitely need to clear the screen to black on every update so everything will appear as it should. Although this for loop seems a bit excessive to me, because you could just make bg a surface that's the same size as the screen, and then just do one blit at 0, 0, which will still cover the whole screen with black and much fewer blits, but I suppose this way still gets the job done. Next we have camera.updatePlayer. This line is going to update the position of the camera based on the position of the player. You can see the update function down here in the camera class. This is going to assign a new value to self.state, which is the current position of the camera. When we created the camera object, we used the complex camera function, so camera funct is going to be the complex camera, and we're passing the camera's current position and the position of what it's focusing on, which is the player. So down here in the complex camera function, left and top are the player's x and y position, width and height equals the camera's width and height. Then we're going to say that L equals negative L plus half the width of the screen, and T equals negative T plus half the width of the screen. This will create values for top and left that are half the distance of the screen away from the player's current position. Then it's going to use some min-max functions to make sure the top left values aren't outside of the camera's width and height, which is the width and height of the level. In the end, what it will do is return a rectangle with a pair of coordinate points that are half the distance of the screen away from the player, unless those points would put the camera outside of the width and height of the level, in which case left and top will just be set to their minimum or maximum values based on where the player is. In short, the camera's position is going to be set by the player object on every update with this camera.updatePlayer line. I'll explain in just a minute how the camera's position is going to affect how the map is displayed on the screen. The next line in our game loop is player.update up, down, left, right running platforms. This player.update function is going to update the position of the player object by passing in the up, down, left, right, and running variables. And the platform array variable is going to tell the player where it can and cannot move to. So we'll scroll down to the player object's update function and see exactly how these variables are used to move the player. First we have if up if up is just short for if up is equal to true. So if up is equal to true, then it's because the up key is being pressed, and we're going to test to see if self.onGround equals true. If the player object is already in the air, we don't want to keep moving it up by pressing up because we want the player block to appear to be jumping, so we'll only move the player up if the player is on the ground. If the player is on the ground, then we're going to set the player's self.yval property to whatever it was minus 10, self.yval minus equals 10. So what this means is if the up key is pressed and the player is on the ground, the player's y-val property will be negative 10. The y-val property stands for y velocity. The y-axis is the axis on which the player moves up and down. In Pygame, the top left corner of the screen is 0, 0, so a greater y value would be further down on the screen. So reducing the y value with a negative number like negative 10 would move the player up. Although this line itself doesn't actually move the player, it just sets its y velocity to say that it is moving up 10 pixels. The player won't actually be moved until we get a little further down in this update function. Looking at the next line, if down equals true, pass, so nothing happens when you press down. If running, we'll set the x velocity variable to 12. Positive values for x increase to the right, so an x velocity of 12 pixels will move the player to the right. If left is true, we have a negative value, so the player would move 8 pixels to the left. If right, the player would move 8 pixels to the right. Then we have if not self.onGround, so if self.onGround equals false, the player is in the air. Y velocity increases 0.3 pixels. A positive y value is moving down, so if the y velocity was negative 10, then it would still be moving up, but not as quickly. Once the velocity becomes a positive number, the player would start moving down. And then we have if self.yval is greater than 100, self.yval equals 100. So the y velocity can keep increasing as long as the player is in the air, but they can't fall any faster than 100 pixels. Then we have if not left or right, self.xval equals 0. When the left or right key is released, left or right equals false. So if left or right do not equal true, then x velocity equals 0. The player will stop moving either left or right since its x velocity will be 0 pixels. Now in this next line, the player object will actually be moved using its x velocity variable. Self.rect.left plus equals self.xval. So self.rect.left is the self.rect.x coordinate. Whatever the player's x coordinate was, it increases by the value of the x velocity. If the x velocity is 8, the player's new x coordinate will be whatever it currently was plus 8. If the x velocity is 0, the player object's x coordinate remains the same. Next is self.collide, self.xval, 0 platforms. The collide function is this function right here. So the first argument we're passing in is the x velocity. The y velocity we aren't checking right now, so y velocity is just set to 0. Then we're passing in the array platforms, which if you remember from earlier is an array that contains every platform sprite that we created when the level was built. So first we have a for loop, for p in platforms. This is going to loop through every platform that's in the platform array, and for every platform, if pygame.sprite.collideRect self p. So for every platform, we're going to call Pygame's sprite.collideRect function. The first argument is self, which is the player sprite, and the second argument is the platform. What the Pygame.sprite.collideRect function will do is it will take the rect property of one sprite and compare it to the rect property of another sprite to see if they intersect each other. So it will read the rect property of the player and the rect property of the platform to see if they overlap. If they do, then this if statement will return true and the code underneath it will be run. First is if is instance p exit block pygame.event.post pygame.event.event quit. What this if statement does is test to see if the platform is an exit block. Earlier, when we created the level, the letter E could be used in the level array to create an exit block. There weren't any in the array, so no exit blocks were created, and this statement would never return true. But if there were an E in the level, then an exit block would be created, and if the player collided with it, it would call the quit event, and the program would end. The next test, if there was a collision, is if xval is greater than 0, self.rect.right equals p.rect.left. If the x velocity is greater than 0, it's a positive number, so the player is moving to the right. So if the player collided with a platform and is moving right, self.rect.right equals p.rect.left, so the right side of the player rectangle is equal to the left side of the platform rectangle. So as long as the player is moving right and colliding with a platform, it can't move any further to the right. The right side of the player rectangle will always just become equal to the left side of the platform. Next we have the same thing except moving to the left. X is less than 0, so the player is moving left, and the left side of the player rectangle will always equal the right side of the platform it's colliding with. So the player can't move any further to the left if it's colliding with the platform. When we called the collide function, we said that y equals 0, so y isn't greater than or less than 0, so neither of these statements will return true. Back in the update function, self.rect.top plus equals self.yval. The value of the y velocity is added to the player's rect.top property, which is its y coordinate, so its y coordinate is increased, affecting its position going up or down. Then self.onGround equals false. We always assume the player is in the air before testing the y collisions. Then we do the y collisions by calling self.collide. The first argument is the x velocity, which we aren't testing, so it equals 0. The next argument is the y velocity, and the third argument is the platforms. So again, we're looping through all the platforms in the platform array to see if there is a collision. If there is, we don't have to worry about the exit block because there aren't any. X isn't greater than or less than 0 because it equals 0. Then we have if y is greater than 0, which would be if the player is moving down, self.rect.bottom equals p.rect.top. The bottom of the player rectangle equals the top of the platform rectangle, so the player can't fall any further. Self.onGround equals true because the player has landed on a platform, and y velocity equals 0 because the player is on the ground and no longer falling. Last we have yval is less than 0. The player is moving up and it's colliding with a platform, so the top of the player rectangle is equal to the bottom of the platform, so the player can't move any further up. That will be it for the player.update function, so we can go back up to the main loop and look at the last few lines of code. We have for E in entities, screen.blit, e.image, camera.apply E, so another for loop. Entities is a sprite group that contains all of the game's sprites. So for each sprite in the sprite group, we're going to blit them to the screen using their image property. And for the position on the screen, we're going to pass the sprite itself to the camera.apply function. That function is going to read the sprite's rect property and create a new rectangle that says where the sprite should be in relation to the camera. So the sprite will be drawn half the distance of the screen away from the player, unless it's the edge of the level. Then finally we have pygame.display.update. This function is in the main loop because it needs to be called every time the display is changed. You can use screen.blit as many times as you want and the display surface will be changed, but none of those changes will show up on the screen until you call this display.update function. This function is what actually draws the display surface to the screen. So that's it. Now that we understand all this code, we can run through it real quick, and it should seem very simple. Starting at the top, import Pygame, set our screen dimensions, initialize Pygame, initialize the display to create a window, set a caption if we want, create a game timer, create our input variables, create a background surface, create a sprite group to hold our sprites, create our player sprite, create an array to hold our platforms, then create the platforms and add them to our sprite group, find the size of the level so we can create the camera, add the player to our sprite group, use our timer to limit the game to 60 frames per second, set up our input handler, draw the black background, update the camera to follow the player, update our player with our input variables and platform array so it can move, draw all the sprites in the entity sprite group with the camera applied, and then update the display so they appear on the screen. Pretty easy stuff once you understand it all. And now that we do know how it works, it'll be easy to change the script to make whatever kind of 2D platforming game we want. Although that will have to wait for the next video, so thank you very much for watching. I hope you found this information useful.